So on the warm-up here, you've got 3 pieces. Much trickier than the one we did one example in the notes last time. This is obviously harder than that. You can still look at where the endpoint is going to be, but you also want to be aware of what's going on as far as just transformations of the graph and what the general shape of these parent graphs look like, so that you don't just end up drawing lines when they're not linear graphs, okay? So the first one, that's a square root. We know what that graph looks like. Looks to me like it's been flipped over the x-axis, shifted right 3, and shifted up 2. So this is not like the final graph for that, but let's just draw on here what that looks like. So if you think about your parent graph dots, 4, just throw those on there. I'm flipping it over the x-axis. I'm going right 3, 1, 2, 3, and up 2. So flip, right, 1, 2, 3, up 2. 1, 2, 3, up 2. So let me get rid of those initial dots. So that's, if I was graphing the entire thing, that's what the first graph would look like. But I don't want the entire thing, do I? No, I want to start at 4. So if I've already got it on my graph, but you could certainly plug the 4 in and go, okay, 4 minus 3, that's 1. Square root of that is 1. Opposite would be negative 1 plus 2 is 1. So I've got the point 4, 1. So I know I don't need this, but I do need this guy down here. Now, should that be an open or a closed dot? Open, good, okay. So that, it's hard to tell that it's still a square root curve because my graph's pretty small. But that's your first piece of the piecewise. You guys have questions on that one? Okay, there. Okay. Second one is this absolute value one. So again, multiple things you can think about here. We can certainly find the endpoints. That's a good thing to do. But I also want to be aware of what this graph is doing. So it's the absolute value function shifted right 2, up 1. Okay, so like you have that vertex in your mind. I would go ahead, and if that is in the region, plot that. So right 2, up 1. You guys see how that's my vertex? And then I'm just graphing it between 1 and 4. Well, you know what the absolute value function looks like. You can certainly plug the 1 in. That one, sorry, should be open. Or you go, okay, I know that this is what the absolute value graph does. And there's my little absolute value piece. Again, you could plug the 1 in and go, okay, when I plug a 1 in, 1 minus 2 is negative 1, absolute value is 1, plus 1, 2, plug the 4 in, 2 plus 1 is 3. But just be aware you're not connecting those with a straight line. Okay? You have to know which part of your absolute value function you're graphing. Okay, questions on that one? All right, then our last piece here is a cubic. Looks to me just like a cubic function moved up 1. So I can think about the parent graph in my mind and go, okay, visualize that graph. I can also plug in the endpoint. Plug a 1 in, I'm going to get 2. Now this is what was happening on MathSpace for a few of you guys. You knew that one endpoint should be open, but it overlapped with a closed endpoint. If you left it open, MathSpace was going to count that wrong because that point is actually a part of the graph. Like it fills in the open circle, if you will. So it's good that you guys were aware, like, oh, but that should be open. Realize though, when you plug in or when you're graphing the one that's it's included, if they overlap like that, you have to fill in that dot. Okay. And then you can plug in, or you can go, okay, I know my shape because this is cubic. And there's my graph. Give me a second, guys, to look at that. Hopefully you can see the shape of the cubic there. You're getting just that one point past the center. It's trickier when they're not all lines, okay? It's definitely more to think about. Anybody questions? How many of you got it right? I got all three pieces, okay? Good. Any other questions before we start our notes? If you, like, if when we graphed them in class last time, were you like, oh, these are kind of all new to me? Like you didn't know them well? That's okay. I just want to make sure I'm in the same spot as you there. I would honestly go back and just make yourself draw them, like just write out the functions and just practice them over and over. I know that's like not a real fun way to do it, but the best way to just get those parent graphs, just those 7. And really even the line you probably don't need to practice, and the rational you're not really going to see much of. So those 5 in the middle, if you know those well, it'll be good. Okay. All right, guys, let's jump into notes then. Last section in Unit 1. So today we're talking about operations with functions, composition of functions, and finding inverses and proving if functions are inverses of each other. So we got a lot of algebra happening today. Yes. All right, so first we just need to kind of define function operations, or really the domain of our function operation. The domain of the new function contains those values common to the domains of the individual functions. So jot it down and then I'll explain a little more. So what this is talking about, you're going to have at least 2 functions that you start with, like an f of x and a g of x. And then you're going to do an operation with those 2 functions. You might add them, divide them, multiply them, something like that. The final domain of what your answer is can only contain values from the original functions you started with. So even if at the end, when you simplify, you don't have certain restrictions anymore, you have to look at the pieces you began the problem with. Okay, so you'll start with those domain restrictions from the very beginning. So let's look at some examples. All right, so I'm going to give you f of x is equal to x over x minus 1. And g of x is equal to x squared minus 1. And then we'll do several problems with those. Our first one's going to be f of x plus g of x. All right, so I'm actually going to just add these two functions together. And then for all of these, we're going to state the domain at the end. Okay, I didn't put directions up here for you, but that's what we're doing. We'll do the operation, and then we'll state the domain. So f of x plus g of x, I'm going to take x over x minus 1 and add it to x squared minus 1. And how do I add those together? What do I need? How do I add fractions, guys? Common denominator. Remember this x squared minus 1, that's over 1. So my common denominator is x minus 1. That means I have to take this numerator and denominator times x minus 1. So I now have x. I'm going to just go ahead and multiply that out. So x plus x cubed minus x squared minus x plus 1 all over x minus 1. Are you guys okay with me doing that in one step? And they've got a common denominator, so I can put them all over that. Put them all in one fraction. We okay there? All right. I know you might have some rusty algebra skills here, so let me know if I lose you on a step anywhere. All right, so my final answer then, I'm just going to combine my like terms, so I'll have x cubed minus x squared. My x's are going to cancel, plus 1, and then over x minus 1. I need to state the domain next to it. And there's no factoring, nothing's going to cancel, no reducing our fractions here. That's just your answer of f of x plus g of x. Anybody thoughts on the domain? What can x not equal here? Yeah, go ahead. 1. Yeah, x can't be 1. And now there's a couple reasons x can't be 1. From our final answer, we see that's the denominator of the fraction, and I'm like, okay, x can't be 1. But also, way up here in this original f of x, can x equal 1 here? No, so you're starting all of these problems knowing, okay, x can't be 1. This one doesn't give me any restrictions because there's no fraction and there's no square root. Okay, but you're starting every time going, all right away, x cannot be 1. So that's got to be part of your domain. Which again, you see it in the final answer here. You won't always see it in the final step though, so it's good to note it at the beginning. So if x cannot be 1, that means negative infinity to 1, union 1 to infinity. That, all of that is your final answer. Questions on the first one? Let me move it up for you, sorry. There's some checks in the back. It's tough to see. do another operation. Let's do f of x times g of x. All right, so hopefully you wrote f of x and g of x down up above. So f of x was x over x minus 1. And g of x is just x squared minus 1. I'm going to go ahead and write it as a fraction, putting it over 1, just so we don't lose anything there. So should I just start multiplying right away? I mean, I could. It's going to make more work in the end. What could I do before I multiply? All right, we're going to factor, guys. So I've got x. X squared minus 1, that just factors into x minus 1, x plus 1. So all of that combined is my numerator. My denominator is just x minus 1. Now what do you see? Yeah, good Lauren, we can get rid of the x minus 1s. Those cancel. You can only cancel factors, okay? You can't cancel individual terms, but you can cancel factors. So my final answer is I would take x times x plus 1, or if you multiplied it out and told me x squared plus x, that would be great. I need the domain. All right, what's my domain, guys? Yes, the same as before, right? Now, if you just look at the final step, you're like x squared plus x. There's no fractions, there's no square roots, anything like that. You're right, but that's not the only place the domain comes from. Remember, you have to look at these original functions that you plug in. So right here, x cannot be 1, so that's where my domain ends up. I have everything but 1. So negative infinity to 1, 1 to infinity. Yeah. Sure. All right, we'll do one more with these two functions. Let's find f of x divided by g of x. All right, guys, so I'm going to write x over x minus 1 over x squared minus 1. And again, I'm going to put that over 1 just to keep the same number of fraction levels going. So how do I divide fractions? There's some flipping and some multiplying, yes? Which one gets flipped, or does it matter? Yeah, what do you think?
I think the equation on the bottom, you take the reciprocal of it, and then you multiply the two with each other.
Exactly. So I really have x over x minus 1 times 1 over x squared minus 1. All right, dividing fractions, multiply by the reciprocal. So my answer here, I only have an x in the numerator, so I know nothing's going to cancel out here because I've got all these factors happening in the denominator. So I can leave it as x over x minus 1 times x squared minus 1. Or if you like factoring, you could say x over x minus 1 times x minus 1 times x plus 1. That would also be the same. Does that make sense? I'm just factoring that second factor. And then I need the domain. Yeah, go ahead. Part of it is the same, but is there anything else that x can't equal?
X can't equal -1.
Right, so it still can't equal 1 like before, but we have this extra, this factor. This one's going to also say it can't equal -1, okay? So good start. So negative infinity to -1, -1 to 1, 1 to infinity, okay? So either way you want to write the fractions, and then the domain is there. All right, questions so far? Okay, let me give you a couple of new functions, and then we'll do 2 more of these. So I guess that was example 1. So this time your f of x is equal to x over 2x minus 1. And g of x is equal to x minus 2 over x minus 1. First one I want you to find is f of x minus g of x. So I want you guys to try this one on your own. And state the domain at the end, okay? I see a lot of you are getting stuck on the common denominator part. So we're doing x over 2x minus 1 minus x minus 2 over x minus 1. Okay, you can't just multiply by one number and make these denominators match. Okay, they're completely different denominators. Your common denominator is 2x minus 1 times x minus 1. Okay, you have both factors in there. So this first fraction, you're taking both numerator and denominator times x minus 1. This one, you're taking them both times 2x minus 1, okay? So try from there. And be careful with your signs. Very easy to mess up a negative in your numerator there. Keep working from there. Did you get there? Okay, good. Another minute here, guys. All right, guys, let's go through it and see how you did. So multiplying on this first fraction, I've got x minus 1 times x, so that's going to be x squared minus x. Now, what you want to be careful with on the second one here, yes, I'm multiplying these two, but I also have a negative out front. So I'm going to go ahead and write it, that negative, and then put everything in parentheses, just so I don't screw up my sign here. So 2x times x, that's going to be 2x squared. Then I've got minus x minus 4x, so that's going to be minus 5x. And then negative 2 times negative 1, that'd be plus 2. Okay, but does that make sense what I'm doing with the parentheses there? Okay, don't screw up your negative. Then I can simplify. So really I've got x squared minus 2x squared, which is negative x squared. Negative x minus negative 5x, that's going to be plus 4x, and then minus 2 at the end. Okay? over my 2x minus 1 times x minus 1. How do we do on the numerator? Got it? Okay, good. Or if you didn't, hopefully now it makes sense. All right, what's my domain going to be? Yeah. Perfect. Negative infinity, hopefully I can squeeze it in here, to 1/2. 1/2 to 1. 1 to infinity. Good. Make sure you always put those in order. 1/2 is smaller than 1. Okay. All right, so there's your full answer for that one. Questions? And guys, don't hesitate. If you're missing something, go ahead and ask.
For the full answer, do you have to put what x can't equal or just simply
So you think about what x can't equal, like you think about those domain restrictions, but then your answer is how you turn that into the domain. Does that make sense?
the state is like x can't equal?
No, you don't have to write that. That's more just your process in your brain to get to the domain. Okay? All right, so same f of x and g of x. Let's try again. Let's do f of x divided by g of x. So you guys try again for me, okay?
Yeah, I remember.
Yeah.
Do you want us to
You mean like multiply it out?
Yes. Okay.
All right, walking around, looks like lots of you got there, so let's go through it. This one's simpler algebraically. You're going to have all the common denominator stuff to deal with. So we've got x over 2x minus 1 over x minus 2 over x minus 1. Okay, we know when we're dividing fractions, x over 2x minus 1 times x minus 1 over x minus 2. Multiply by the reciprocal. If you want to multiply this out, you certainly can. If you just want to say x times x minus 1 over 2x minus 1 times x minus 2, I'm good with that. Questions like this, make sure, MathSpace will tell you if it wants it in factored form or not. So just read the directions as far as that goes. Now, the tricky part, guys, the domain. So if I look at the final answer, it just looks like, all right, x can't be a half and x can't be 2. What else can't x equal to? 1. Yeah, remember you have to look at those original functions. And from g of x, right in the start here, x cannot be 1. So your domain is long. It's negative infinity to a half to 1, 1 to 2, and then 2 to infinity. Okay? Questions there? All right, so that's the basic idea with operations. We're going to do composition next, which you've done before, but we might need a review on that too. Get a new page here. All right, so let's try, you've got 2 new functions here. So for a third example, we've got f of x is equal to x squared plus 2x. G of x is equal to x minus 4. And we are going to find f of g of x. Now, a couple ways that can be written with notation. I think that's what you guys are comfortable with, right? Like you've seen that before. Okay. It can also be written f of g of x. That doesn't just say fog. It's like a little composition notation there. So those mean the same thing, okay? So guys, what does it mean to do f of g of x? Right, yeah, you're taking that entire function and substituting it in. So anywhere there's an x in the f of x, I'm replacing it with x minus 4. So I've now got x minus 4 quantity squared plus 2 times x minus 4. So that's going to be, and this we do want to multiply out because we could simplify it by multiplying. So I've got x squared minus 8x plus 16 plus 2x minus 8. So I end up with x squared minus 6x plus 8. So there's my composition. Now let's talk domain. Okay, so you obviously have to look at your final answer as part of how you figure out the domain. So x squared minus 6x plus 8, there's no fractions, there's no radicals, so that would just be all real numbers. The other piece you look at, you don't look at both the f of x and the g of x. You look at whichever one is inside. So we would care in this case about the g of x function. Okay, so you would want to double check the domain of g of x and see if there are any restrictions there. Okay, so it's always just the inside function. With g of x, do we have any fractions or radicals?
No.
No, so my domain is just negative infinity to infinity. And notation-wise, don't write just that, okay? I would not give you full credit for that. Write negative infinity to infinity. If you want to do like the real number symbol, you would need to do x such that x is an element of the reals, like proper set notation. I'm guessing that's not what you guys want to do, so yeah, go ahead. Let's just stick with negative infinity to infinity for anything that's a free response type question for me, okay? All right, questions on that one? That was a pretty simple composition one to start with. Let's throw some more rationals in there. So let's do f of x is equal to x over x plus 2. And g of x is equal to 1 plus x over x minus 3. And we are going to again find f of g of x. You guys want to give it a try, or you want me to walk you through it right from the start? Give it a try? Okay. Lots of multi-leveled fractions. Definitely have to find some common denominators here. 1.
So, we're going to start with the G of X and this plus the G
And your final.
and
All right, guys, let's go through it. Some of you are there, which is awesome, and some of you are on step one. That's okay. Let's walk through it. All right, so f of g of x, that means I'm plugging the g of x function into f of x. And if you want to write it x plus 1 instead of 1 plus x, you can certainly do that. So I'm going to do that. Plus x over x minus 3, and then over, and plus 2. So each of these x's gets replaced with this entire thing. Okay, that's where you have to start. I'll put the 2 over 1. We can't just right away go, oh, I'm going to flip things and multiply, because I don't know how you would flip that denominator when there's plus in between your fractions. It's not going to work. So I need a common denominator down here. It would be x minus 3. All right, so I've got x plus 1. Or 1 plus x, doesn't matter, over x minus 3 over x plus 1 plus 2x minus 6 all over x minus 3. Move up just a little bit. It's ugly before it gets nicer. All right, I just distributed the 2. That's where the 2x minus 6 comes from. Okay, so I've got x plus 1 over x minus 3. I know I need to flip and multiply. I'm going to do that while I simplify this a little. So multiply, the x minus 3 would be up here. X plus 2x is 3x. 1 minus 6 would be minus 5. So those cancel. So your final answer should be x plus 1 over 3x minus 5. Any questions on the x plus 1 over 3x minus 5? Okay, then looking at the final answer, what can x not equal from just the final fraction?
X can't equal, so just from the final.
Just from the final, yeah.
So, 5/3.
5/3, good. But then I also have to go way back up to the top. And remember, I care about the inside function, so I only care about g of x. So look at g of x. What else can x not equal, guys? Yeah, 3, good. So now you just have to make sure you put those in the right order. So we have negative infinity to 5/3, 5/3 to 3. 3 to infinity. Oh, there's your final answer. So guys, this is trickier than most of your questions on MathSpace are going to be. Oh, pencil sharpener's on the back shelf there. But this is more like what your free response question might look like. Okay? So be aware, remember your test is partially MathSpace, partially free response. I would consider the MathSpace more the like basic skills factor of it, and then the free response is more the thinking and applying the ideas. I don't want to say the trickier questions, but you know what I mean, like the deeper level type of questions are going to be on the free response part. Okay? So, questions on this? Okay. Now we're going to talk inverses. I still don't remember it. Okay. Anybody remember anything about inverses? Like inverse functions? I'm really excited about inverses. All right, well, we'll start from the basics then. All right, so inverse functions. If you're trying to find the inverse of a function, that's where you switch x and y and solve. So switching x and y, that's always true with inverses. Graphically, they are reflected across y equals x. And if a function is 1-to-1, that means the original function and the inverse are both functions. And you can check that with the vertical and horizontal line test. Draw pictures of this. So let me give you 2 examples. Start with that cubic graph. So is that a function? Yes. Yeah. It passes the vertical line test, right? You guys remember that from, I don't even know if you learned it in Algebra 1, I can't remember. Anyway, you've learned the vertical line test for a long time. The horizontal line test, same idea, but you check horizontally. What do you think? How many times does the horizontal, each horizontal line touch your graph? just once. So this is a one-to-one function. So that's what one-to-one looks like, okay? The original is a function and the inverse would be a function. What if I start with quadratic graph? Is that a function? Yeah, quadratic graph's a function. Is it one-to-one? No, good. So if I drew a horizontal line, it's going to touch it more than once, so not one-to-one. Okay, so what we're going to do with inverses, and the reason we do this with our composition, is we're going to prove whether or not two functions are inverses of each other. And the only way you can prove that is with composition. I think we're on example 5. So that's what we're going to do first. Are f of x and g of x inverses? What that means is you're going to prove it, okay? So f of x is equal to 2x minus 6, and g of x is equal to 1/2 x plus 3. So really important, guys, when I'm asking you, are they inverses of each other, I'm not asking you to find the inverse of one and see if it's the same as the other ones, okay? That's not what I'm looking for here. That's a separate set of skills. The way you prove it is with composition. You have to find f of g of x, and you have to find g of f of x. Okay? If both of those simplify to just x, then they're inverses of each other. And you got to pay attention to notation here. Label for me. Here's f of g of x. Here's g of f of x. Don't just kind of randomly scattered start doing composition. Okay? All right. So I'll do f of g of x first. So I've got 2 times 1/2 x plus 3 minus 6. And show your work here. If I distribute, I'll have x plus 6 minus 6. So that one is just x. We're obviously doing a pretty simple one here as the example, but then I go over to the other side and I have to do g of f of x. So I've got 1/2 times the quantity 2x minus 6 plus 3. So when I distribute, I get x minus 3 plus 3, which simplifies to just x. So both f of x and g of x simplify to just x. So I can say, therefore, which are these 3 little dots, f of x and g of x are inverses. So now as you're going through these, if you do one and you start with f of g of x and you get like 7x plus 2 is what it simplifies to. Okay, that's definitely not just x. So you can stop there and say, no, f of x and g of x are not inverses, assuming you didn't just make an arithmetic mistake. But to prove it, you have to show both sides. You have to show both f of x and g of x. Is everybody okay with like the notation and everything with that? Okay. All right, one more example, guys. Okay, you are actually going to find the inverse. So you are given y equals 3 plus x over 2 minus 3x. So how do you find inverses? What do you do?
Replace x and y.
Yep, you switch the x and the y, okay, and then what?
Solve for y.
Solve for y. Okay, so try this one, guys. Anybody stuck after this step? A little bit? All right, guys. I'll give you another minute to try to figure it out. Multiply to get that out of the denominator. And then, guys, you're going to have to get all the y's together. Remember, you can't have like y equals and then still have a y on the other side at the end. So, give me a minute to think. You can chat with each other. No, can't ask her.
I would not pretend I'm just so
Three plus two over yeah. You're telling me it's like yeah, that's don't do that.
Like, I have this other point y on the other side.
No, but that
I'm gonna move that to the other side and then factor in the y. I'll walk you through it here. Because I think a lot of people got stuck there. How many of you really just wish there were fewer y's in this, right? Like, there's just too many y's. Okay, so to get this out of the fraction, like I don't want that 2 minus 3y to stay in that denominator. I'm going to multiply both sides of my fraction by 2 minus 3y. So that's now gone on the right side. And I'm going to go ahead and distribute. So I'll have 2x minus 3xy equals 3 plus y. A lot of people got here and then got creative after that, okay? What you're trying to do is solve for y. So you need to get any term that has a y on one side and all the terms that don't have y in them on the other side. So I'm going to leave the 2x over here, and I'm going to bring over that 3 from the other side. So I'm going to minus 3. I'm leaving the y on the right side, and I'm going to bring over the 3xy. So that would turn into plus 3xy. So let me stop there for a second. All I did was move stuff using, your algebraic properties here. I added 3xy to both sides. I subtracted 3 from both sides. Okay? Put up a little. I'm solving for y, so I'm going to factor a y out on the right. So I've got 2x minus 3 equals y times 1 plus 3x. Now can I get the y by itself? Yeah, what do I do from there? Yes, divide by all of that. Divide both sides by this 1 plus 3x. So I've got 2x minus 3 over 1 plus 3x. And I'm going to say equals y to the negative 1, because remember we were finding inverses, so that's technically what I was solving for, okay? Now, if you moved things to opposite sides, you're going to have the same thing, but just with totally different signs. So I would also accept 3 minus 2x over negative 1 minus 3x. Like that's, doesn't look like it, but that's the same thing. Okay? Right. Leave that up there for a second. Questions, guys? Anything? Yeah.
How come you're able, what happened to the second y?
So you're good to here, right?
Yeah.
Where I have both of them? So ignore what's under there. Think if I distribute it, that'd be y plus 3xy, right? I just factored out the y, since that's what I'm solving for.
Okay.
And then I can move. That's how you can separate it from everything else. Other questions? Your brains hurt a little today? Okay, we got about 5 minutes left, guys. So you do have math space. I think the math space is easier than the notes. Remember, there's always extra practice worksheets on Schoology for you as well. Those aren't for a grade, but it's good if you're like, wow, I really need a little more work on whichever piece of this. You can pick and choose problems to practice on. Then Thursday, catch-up day. Next week, review and test. Okay?